Hello everybody. So what I wanted to go over with you today is how to find the common factor of a polynomial and then of course factor it from there. So let's recall here that we previously have learned how to find a greatest common factor, which is GCF here, of a number. And an example is if we had two numbers here, 24 and 60. The biggest number, the largest number that divides both of these is 12. And you can review on how we found that, but it's always just the largest number that divides both of the numbers. Or if you have more than two, it can be 3 or 4 and so on. But it needs to be the largest number that divides all of the numbers that you're asked to find the greatest common factor of. Now the GCF of finding something with a variable in it is a similar process. What we're trying to do is we're trying to find the variable which divides all of the particular variables. The way that it works for variables is most of the time you'll see variables with exponents and powers, and so what you're looking for is the variable with the smallest exponent. The GCF of two or more of the same variable is the variable which has the smallest exponent. Let's take a look at an example to kind of clarify this. Suppose we want to find the greatest common factor of 12a to the fourth b and 18a squared b squared c. The first step is let's determine what is the greatest common factor of just the numbers. The largest number that can divide both 12 and 18 in this case is 6. So 6 can go into 12 two times, 6 can go into 18 three times. There is no number larger than 6 that can divide both of these. Next, let's take a look at a to the fourth and a squared. We see they both have an a, so that's a plus for this. And because they both have an a, we need to determine which one has the smaller power. Well, this one does. This one over here is a squared, which is smaller than 4. So that's the one that we pick. Now let's move on to b. They both also have b's, so that's good. And we have a b squared and a b to the 1. It's not written, but it's implied that it's a 1. So the smallest of these two is b to the 1. We don't have to write the 1 there. Finally, we have a c. Now we don't need to concern ourselves with the c because the c is not common between the two. So we don't see a c here, and because of that, we don't need to consider it as part of the solution here of the GCF. Because the key word here is c, or the key letter here is c, which stands for common, and c is not common between both of these two here. So this would be the greatest common factor out of these two factors. Okay, let's use this ability now to get the GCF from variable terms and from numbers to factor a GCF from a polynomial. Now I've listed the steps here, and the steps are pretty straightforward. Step 1, we're going to find the GCF. Once we do that, we're going to divide that GCF into each term, which I'll show you what we do there. And finally, we just write the polynomial in factored form. So let's do an example of this. So let's take a look at this example here. We need to factor 5x cubed minus 35x squared plus 10x. The first thing we need to do is find the GCF. So let's figure out what that is. Well, if we look, the largest number that can divide all three of these is 5. 5 can go into 5, 5 can go into 35, and 5 can go into 10. So the largest number here is 5. Now, they all have an x as well. So they have an x cubed, an x squared, and an x. The smallest x that we can use here, the smallest power that we see on the x is this one, which is x to the 1. So our GCF here is simply 5x. The next thing we need to do is that's step 1. So if you saw the previous steps, now we need to divide each of these terms by the GCF. So we have 5x cubed. We're going to divide that by 5x. This gives us, well, 5 divided by 5 goes to 1, and x cubed divided by x to the first, if we subtract the exponents, this just leaves us with x squared. So this, the division of this here gives us x squared. Next, let's look at this negative 35 x squared. Notice that I took the sign with it. So make sure you always take the sign with it. In this case, it was positive. We don't need to write plus 5x3 because positive is implied when nothing is there. But if it's a minus sign, you bring down the negative. Let's also divide this one by 5x. And when we do that, we get, well, negative 35 divided by 5, that's negative 7. And x squared divided by x. Subtracting the exponents just leaves us with x to the 1. So that's that term. Finally, let's divide this last one by our GCF. There we have it. 10x over 5x. Well, these x's go to 1. They cancel out here. And the 10 divided by 5, this is 2. Once you've done this, the way that you write out the factored form is you write it like this. 5x all multiplied into x squared minus 7x plus 2. And that's how you would write this solution in factored form. Now, you don't necessarily have to always write out all of this division like I've done here. I wanted to make sure that you saw what was actually happening. Theoretically, you could just say, okay, 5x goes out here because that's the GCF. You can do this in your head when you get good at it, is what I'm trying to say. But for the next, we'll do another example, and for the next one, I will again do the division this way, just so you can see it. Okay, here's another example. We have 16x squared y plus 8x to the fourth y squared minus 12x to the fourth y to the fifth. Now, the GCF here, again, we got to find, first of all, let's find the greatest common factor when it comes to the numbers. We have a 16, an 8, and a negative 12. The common factor that the largest number that can divide all three of those numbers is 4. 4 can go into 12, 4 can go into 8, and 8 can go into 16. We can't say it's 8 because 8, of course, divides 8 and 16, but 8 does not divide 12. So the largest number here is 4, so that's that part of the GCF. Let's look at common variables now. They all have an x. Which one's the smallest powered x? It looks like it's x squared. And they all have y's, and we need to say which one is the largest, or I'm sorry, the smallest power on the y, and that's this one, which is y to the 1. So that is the GCF, 4x squared y. Now our final answer is going to look like this. And then we're going to have something that goes in there. What we have to do is we have to take each of these and divide them. Let's take a look at this one first. 16x squared y, which is this term, divided by 4x squared y. Well, we can see that this x squared and this x squared are going to divide out to 1, so we can cross those out. Same with these y's, that divides to 1 as well. So all that's left here is a 16 divided by a 4. And 16 divided by 4 is 4. So we write that here. Next, we have this one. We're taking the 8x to the fourth y squared, which is this term here, and then we're dividing this by the GCF, which is down here. The 8 divided by 4, this is going to give us 2. So notice I'm just writing it here now. It's the same thing as we did in the last example. I'm just writing it down here. X to the fourth over x squared, if we subtract the exponents, 4 minus 2, that's just x squared. Because 4 minus 2 is 2. And the same concept here, we subtract the exponents with the y's, 2 minus 1, that leaves us with y to the 1. So we finished these two terms. Let's do this last one. Notice now, again, that I brought this negative sign with it. That's important to do here. So negative 12 divided by 4, that's negative 3. X fourth divided by x squared, well, that, again, we subtract the exponents and we get x squared. And y to the fifth over y to the 1, we subtract 5 minus 1 and we get 4. And there we have the polynomial in factored form. One thing you can experiment with is if I now come back and distribute this in, I'll get back what I started with. So in the last sections, you guys have learned about how to multiply polynomials and monomials and things like that. Now, essentially, all we're doing is going the other way around. We're going backwards here. So we're starting with this and getting to this, whereas before we were starting with something like this and getting to that.